Okay, today we're going to go into section 2.5, which is formulas. And remember, a formula is just an equation with more than one variable. And we've already kind of dealt with some of these before, but this one's just going to kind of go into a little bit more depth. And I'll just go over some of the equations that we've already used that were formulas. So if you think about it, when we go over an area for a rectangle or a square, it's length times width. So I have an L and a W. Also for our perimeter, kind of already used these as well, which is 2 length plus 2 widths. Remember, you see one of those variations on every test that you take, also along with the reciprocal. But if you think of some of the other ones that we've done, I'm just going to abbreviate here our complementary angles, which was x plus y is equal to 90. And then also our supplementary angles, which was x plus y is equal to 180. So we've already used these before, so we're just going to kind of focus on these a little bit and see how we use these to solve different things. So because we were using the perimeter, we're going to kind of use that one to kind of show how we can use these different things to solve our formulas if we only have partial information. Because generally, so far, I've told you for the perimeter, I've told you what both the length and both the width are. So basically, you're evaluating with those. So for this particular one, we're going to say that we have a rectangle. We're just going to kind of draw it out. So we know that the perimeter is 100, and we also know that the length is 40, but we don't know what the width is. So the width is a mystery. So we're going to just write this out. So I can pick either side. I'm just going to go here and say the length is equal to 40. The first thing I want to do is just start with my formula. So I have to know which formula I'm going to use. So my formula is going to be 2 length plus 2 width. So I have to figure out what my width is. So because we've already established all our variables, which are P, our L, and our W, we can just continue to use those. So then we just fill in the information that we know, and then we're left with the information we don't know, which is going to be our answer. So I'm just going to substitute in the P is equal to 100 because we know our perimeter is 100. We know that our length is 40, so that's going to be 2 times 40. And the thing that we don't know is our W, so that's just going to remain as 2W. So remember, once you're down to one variable, you can solve it. You can solve any equation or any formula once you get down to a single variable. You just have to have other information. So once again, I'm just going to work this out. 2 times 40 is 80. Remember, the 100 just comes down. So in order to solve this, still got to get letters on one side, numbers on the other. And because the letters are already on this side and I have numbers on that side, I'm going to continue with that. Generally, I don't, right? I would move them, but it's just easier to subtract 80 from both sides. Whatever I do on one side of the equation, do on the other side of the equation. 100 minus 80 is going to give me 20. This allows this to disappear. This just comes down as a 2W. And then I remember I need to solve for W. I need to figure out what the width is, not what two of the widths are. So once again, I'm going to subtract both of these, or not subtract, but divide both of these by 2. By doing that, that just tells me that my width is going to be equal to 20 divided by 2, which is going to give me 10. So I know that my width is going to be 10. And I can kind of go back and solve that once again. If I say it's 2 times 40 plus 2 times 10, is that going to give me my 100? So 2 times 40 is 80. 80 plus 20 is going to give me my 100. So I know that I've worked it out correctly. And that's just one example. So if I use something else, and it doesn't necessarily have to be a known formula, it can be a formula that's given. Sometimes you will know them and sometimes you won't. But if I use 3x plus 2y, and all of that is equal to 5. Well, I have two variables here, so one of the variables has to be known in order for me to solve this. Other than that, I'm just coming up with a solution set, and we'll kind of cover those a little bit later. So let's just say that I know that the x is 3, but I don't know what the y is. So I have to basically, what I'm doing is I'm solving for y. That's basically what I'm doing here. So, and that's how you solve any solution. You have to kind of break those down. So once again, I'm just going to input what I know. So I know my x is equal to 3. So this just becomes 3 times 3 plus 2x, or I'm sorry, 2y is equal to 5. 3 times 3 is going to give me 9. Still going to go letters on one side, numbers on the other. So how do I get rid of a positive 9? I subtract 9. Whatever I do on one side of the equation, I always do on the other. This is going to give me 2y on this side. Remember, I have a positive and a negative. They don't match, so 9 minus 5 is 4. 9's bigger, it's a negative, so that's going to give me y is equal to 2, 4. Or 2y is equal to negative 4. So once again, divide both of these by 2. That allows this to become my single y, so I'm halfway there, right? I know I got to have a single y in order to solve this. I have a positive and a negative, so therefore I know my answer is going to be a negative. 2 will go in the 4 2 times, and this is going to be my final answer. Now I can go back and kind of put these back in, and then see if both of these will give me a 5. 3 times 3 is 9. Positive times a negative give me a negative. 2 times 2 is 4. And 9 minus 4 does in fact put you right back at 5. So these are real easy to kind of check and see what you have. Now, basically for a lot of things that we use, for an example, if I have 3x plus 2y is equal to 6. So in this particular one, this question is asking you to solve for y. Now, what makes this one different than what we've done before is it doesn't tell you what the x is, which means you are going to have a variable. You're going to have 2 variables left. On some of these, it's easy to move these, but the process is still the same. Anytime, whatever you're solving for, in general, we'll do x, but it could be a y, and it could be any variable. That's right, not really important. Still got to get the variable on one side and everything else to the other. Now, you've heard me say over and over that the letters on one side and numbers on the other, because most of the time we're trying to solve them. And remember, I said sometimes we're not always trying to solve them, and this is one of those particular cases. So I have to get everything else to the other side. So what that means is I have to subtract 3x, because that's the opposite of positive 3x. Whatever I do on one side, I do on the other. Basically what I'm trying to do is just isolate this y, or get my y on one side and everything else to the other side. So that allows this to disappear. That gives me a 2y. And because these are not like items, all I can do is just rewrite them exactly as I see them. I can't combine them. They're not like items. Process to solve this is exactly the same. Divide both of them by 2 because this is a 2y. Whatever I do on one side of the equation, remember I always do on the other side. This is going to tell you that y is equal to 6 minus 3x divided by 2. Now you can separate these, but really that doesn't need to be done. And that would be your final answer. Now, we can use this to kind of solve a lot of different things. And so, for an example, if I wanted to use this particular way, and if you think of our perimeter is equal to 2 length plus 2 widths. So for this particular one, what I'm going to try to do is I'm going to solve for W. Oops, got too many loops in my W. Anyway, I'm going to solve for W. So that means I need the W on one side and everything else on the other side. Now, I'm going to do this just like with anything else. I'm going to pretend this is a number, and I'm just going to move it to the other side. That will let me to isolate my W. So I'm going to subtract 2L on this side. Whatever I do on one side of the equation, I do on the other side of the equation. This allows this to disappear, and then my 2W is what I'm left with. These two are not like items. They're different variables. So the only thing I can do is rewrite them exactly as I see them. Now remember, I want to solve for W, not 2W, so I still have to divide both of them by 2. Now that's going to allow this side to become down to a single W. Whatever I do on one side of the equation, do on the other side. So this is going to be your final answer. Now, if I was doing the opposite of that, so for an example, if I was trying to solve for L, so this one solves for W. If I was trying to solve for L, that means I need to move this to the other side. So it's almost the exact same thing, I'm just moving something different. So all I'm doing is subtracting the opposite of it from one side to the other. Remember, whatever I do on one side of the equation, do on the other. This becomes P minus 2W. And then I'm just left with 2L on this side. Divide both of these by 2 because I'm trying to solve for L, not for 2L. That allows this to come down to a single L. Whatever I do on one side of the equation, do on the other. And of course, this is just going to be your final answer on this. Now, notice how these answers are very, very similar. And if you notice, really the only thing that's happened is the W has swapped positions with the L down here. That's the only thing that makes them any different. I've just moved those around. So that's an example that we can use of a formula that we've already used and had working for us. I'm going to continue this on the next video.